Power meters have been available to recreational cyclists for about 15 years, and in that time, they have gone from a tool used exclusively by professional teams with dedicated sports scientists to a standard feature on bikes sold at mid-range price points to weekend riders who do most of their training by feel and finish most of their rides at a coffee shop. The price dropped from over $1,000 for a basic unit in the mid-2000s to under $300 today for a crank-based system accurate enough for serious training use. The democratization of the technology is real, and the cycling industry is genuinely proud of it. What the cycling industry is less forthcoming about is the gap between owning a power meter and actually using one in a way that produces measurable fitness improvements, because that gap is wide, poorly understood by most buyers at the point of purchase, and almost never discussed honestly in the product reviews and YouTube unboxing videos that shape most buying decisions in this category. The majority of recreational cyclists who own a power meter use it primarily as an expensive speed display that shows them a number they find motivating in the moment and do nothing systematic with afterward. The number goes up when they push harder. The number goes down when they ease off. The ride gets logged to a platform that generates colorful charts. Nothing changes about how they train. Nothing changes about how fast they get. The power meter was a purchase decision made on the basis of what professional cyclists use and what the most enthusiastic members of their local club ride with, not on the basis of a clear understanding of what structured, power-based training actually requires and whether they were genuinely prepared to do it. This is not a reason to avoid power meters. It is a reason to understand exactly what they are not, and what the difference between those two things costs a rider who buys the device without buying the methodology that makes it useful. A power meter measures the force applied to the drivetrain and the speed at which the drivetrain is moving, then calculates the rate of work being done in watts, which is the standard unit of mechanical power. The number is objective in a way that heart rate, perceived exertion, and speed are not. Heart rate is affected by heat, hydration, fatigue, caffeine, stress, and sleep quality, which means the same heart rate on 2 different days can represent 2 very different physiological states and 2 very different levels of actual work. Speed is affected by wind, gradient, road surface, and drafting, which means a rider can feel like they are working extremely hard and be moving slowly, or feel like they are cruising and be moving fast, with no reliable relationship between the sensation and the output. Power is none of those things. 200 watts is 200 watts, regardless of wind direction, temperature, how tired the rider felt getting out of bed, or how steep the road is. That objectivity is genuinely valuable for training because it allows a rider to prescribe and measure specific doses of physiological stress in a way that heart rate and perceived exertion cannot replicate with the same precision. The problem is that objectivity without methodology is just a number. A thermometer is an objective measurement tool. Owning a thermometer does not make anyone better at managing their health. It makes them better at managing their health only when combined with an understanding of what the number means, what range constitutes a problem, and what actions the number should prompt. A power meter works exactly the same way, and the cycling industry has done a remarkably poor job of communicating that parallel to the buyers it has been selling power meters to at rapidly decreasing price points over the past decade. The methodology that makes a power meter useful rather than decorative is built around a concept called functional threshold power, which is the maximum average power a rider can sustain for approximately 1 hour of all-out effort. That number, once established through a standardized test, becomes the reference point around which all structured training is organized. Training zones ranging from easy aerobic work at the low end to maximal neuromuscular efforts at the high end are defined as percentages of functional threshold power. A rider training with zones knows that a session calling for 2 hours at zone 2 means maintaining power between roughly 55 and 75% of their threshold continuously, and they can use their power meter to enforce that prescription with a precision that riding by feel cannot approach. The gains from this kind of training are real and well documented. Riders who move from unstructured riding by feel to structured power-based training with a coherent periodization plan consistently see functional threshold power improvements of 10 to 20% over a 6-month period, which translates directly into riding faster on every terrain type and at every distance. If you want more honest examinations of which cycling products actually deliver on their performance promises and which ones deliver primarily on their marketing promises, subscribing means you will not miss the next one. But here's the part the industry buries beneath the specification sheets and the professional endorsements. Achieving those gains requires testing functional threshold power every 4 to 6 weeks as fitness changes, adjusting zones accordingly, following training plans that prescribe specific session types in a specific sequence across weeks and months, recovering adequately between hard sessions and tracking performance trends over time rather than evaluating individual rides in isolation. That is a level of systematic commitment that the majority of recreational cyclists who purchase power meters have neither the time nor the structured coaching support to maintain consistently, and the product marketing that drives power meter sales does not prepare buyers for that reality with anything approaching honesty. The honest verdict on power meters sits between the two positions the cycling community tends to occupy loudly. They are not a scam. The technology works, the measurements are accurate, and the methodology built around them is supported by decades of sports science research conducted at the professional level and validated across amateur populations large enough to trust. A rider who purchases a power meter invests the time to learn how to test and set their training zones correctly, follows a structured training plan built around power targets, and maintains that approach consistently across a full training cycle, will almost certainly ride faster at the end of that cycle than they would have riding the same hours by feel. That is a real return on a real investment, and it deserves to be stated clearly. The scam, to the extent that the word applies, is not in the device. It is in the gap between what the device promises implicitly through its marketing and professional association and what it actually delivers to a rider who buys it without the surrounding methodology. The cycling industry has sold power meters to hundreds of thousands of riders on the strength of what professional cyclists do with them, without adequately communicating that professional cyclists use power meters inside a training infrastructure that includes coaches, periodized annual plans, recovery protocols, and nutritional support that most recreational riders do not have and cannot easily replicate. The device without that infrastructure is a sophisticated odometer. It measures something real. It changes nothing on its own. The riders who get faster with power meters are the riders who treat the purchase as the beginning of a process rather than the end of one. And that distinction is the thing worth understanding before spending $300 on a crank spider that the industry has been careful to make feel like the answer rather than just the first question.